Geometers, welcome to another video lesson. Today, though, is a somber day as we mourn the loss of the Tennessee Titans. The Denver Broncos put up a valiant effort, but poor game management at the end of the game cost us the win. Your task for today is we have the Unit 2, Lesson 3 on rotations, and then our homework again is in that Delta Math location, again on rotations. There's also a problem set on identifying and kind of combining some of the other transformations that we've looked at so far. So it'll be good practice for getting ready for that assessment coming up. All right, moving on to our third transformation that we'll be talking about this quarter. We have rotations, and so our definition of rotations is a turn of a certain angle about a point that is called the center of rotation. We talked about this a little bit in class yesterday. I think especially during 7th period, we talked about this quite a bit. But the center of rotation isn't always necessarily the origin, which is the 0, 0 point where the x, y axes cross, but it can be. So oftentimes it will specify. If it doesn't specify, then we can typically assume the origin when it's not specified. Another thing to keep in mind, we'll kind of slide over to the side here to give a little more space, is unless it specifies, so unless otherwise specified, we typically assume rotations to be counterclockwise. Rotations are counterclockwise. You might see that as CCW for short. All right, so again, unless otherwise specified, we're going to assume counterclockwise. Counterclockwise, rotating that direction. All right, let's look at an example. So we have here example 7, continuing in our all notes. We have find the image of point P, which is at -2, -2, after being rotated 180 degrees about the origin. So we're going to start off by graphing our point. So we're going to go left 2, down 2, right there. There's P. And then I want to rotate this 180 degrees. Now, one thing to note that's special about 180 degrees is this will be the same if you go counterclockwise or clockwise. So this first one is counterclockwise, going that way, and then clockwise is going this way. So let's look at what happens, how we would go about doing this. And we're going to explore this in class today. So if you're watching this without having watched the class video or done the exercise from in class today, then some of this might not make the most sense in the world. So go back and watch those, watch the video and do the Desmos activity from class today. But there are these shortcuts that we have for our rotations. So our shortcut for 180 degrees is if I have some point, we'll do this in red, at A comma B, you could also use X and Y, then where it's going to go, that's what this symbol means, is we're performing the transformation, describing where how this is changing. They are going to go to -A and -B, which means, I guess a better way to say this is the opposite of A and the opposite of B. So because P right now is at -2, -2, P, we would have -2, -2. To go to the opposite of these two values would be to go to 2, 2. So the new point is going to be at 1, 2, 1, 2. We'll do the new point in purple. This is P prime. And to show you a few things about this, and we'll highlight this in orange, is if we look at this line goes through the origin, and the distance from the origin to P is 2 diagonals here. Distance from the origin to P prime is also 2 diagonals. And you can see on here that this has gone 180 degrees because it's across a straight line. That is one way to view or visualize this rotation of 180 degrees. All right, let's look at another situation, this time with a different rotation. So this time, we'll highlight in pink here. We're taking the image of Z, or finding the image of Z. Z is our pre-image. And we're rotating it 270 degrees. Again, about the origin. So our origin is our center of rotation. We're going to take Z, which we'll mark on our graph in pink here. So Z, we're going to go over 1 and then down 4. So we're going to go to the right 1 and then down 1, 2, 3, 4. So that is going to be right here. There is Z. And since it doesn't specify, we're going to assume this rotation is going to be counterclockwise. So again, I'll show you the kind of shortcut method and then represent it visually to give you kind of understanding from both viewpoints. But that activity we did today is really going to help you better understand some of these shortcuts. So for 270 degrees, if I was to take this, and I'll use X and Y this time, show you a way that you could write it that way as well. For 270 degrees counterclockwise about the origin, we would take this and we would say X, Y, those points, the change that's going to happen to them, that's what that arrow means, is they're going to go to Y and then the opposite of X. So you'll notice that X starts in the X coordinate position, X comma Y. And then we're going to take X and it's going to become the opposite value that we're given, and it's going to switch to the Y part of our coordinate point. Y stays the same in terms of its positive or negative status, but it's going to switch to the X position. So if I look at the point Z, we take 1, negative 4. The change that's going to happen is we are going to take the X value, which is 1, and we're going to move it to the Y position, but it's going to be opposite, so that's going to be negative 1 here. Y value doesn't change its sign, it stays negative in this case, but it's going to move to the X position, so it's going to negative 4, comma, negative 1. Let's do this in like a dark purple to make it a little bit more obvious, so highlight that here as well. So this point here is going to be my Z prime. So negative 4, so I'm going to go left 1, 2, 3, 4, and then down 1. Here is my Z prime. All right, so I said we'll show this graphically as well, just to give you an idea of what that looks like. So let's use our green here. So one thing I can do is I'm going to draw a line that goes through the origin here. There. I'll draw another line. Also goes through the origin here. And what I'm doing is at these points, so since I'm over 1 and down 4, I'm going to go over 1 and up 4 on this side. So that creates this straight line. So this would be a spot where if I had rotated Z 180 degrees, it would go there. And then for this one, again, kind of cheating a little bit by using my shortcut, since I'm over 4 down 1, I'm going to go over 4 up 1 and continue that slope. And what happens is these two slopes become opposite reciprocals of one another, which is to say that they are perpendicular to one another. And I'm going to put some spots along the way here. So right here, make that a little bit darker. Here and right here. Those are spots that would be equal distance from the origin. as z and z prime currently are. And so you can see that if I go from this spot to this spot, I've rotated 90 degrees one time. This spot to this spot would be 90 degrees a second time. This spot to this spot would be 90 degrees a third time. So in total, I have 90, 180, 270 degrees. And that's one way to see myself landing here at z prime. Let's look at another example here for example 9. So this time we're going to apply the same concept, but to a figure rather than just a single point. So let's look at triangle XYZ. So we'll do XYZ in, let's get some fun colors on the board here. Let's do X in this kind of off reddish magenta color here. So X is at 0, -1, so X is right there. Y we'll do in this kind of fun tealish color. Y is at 1, 2. Y. And then Z we'll do in a fun purpley color here. Z is at 1, 2, 3, 4, 1. There's Z. Them all with this kind of charcoal color here. All right, there we go. There's our triangle XYZ. And then again, we want to do this 90-degree rotation about the origin. Going 90 degrees, again, about the origin. So one of the things that I can do for this is, again, apply that shortcut. So for X, so it starts at 0, -1. And again, just a reminder, start with A and B this time. So our shortcut for this 90 rotation, if I start at A, B, for 90 degrees, it's going to go to the opposite of B, A. So X prime then, kind of in an orangey color. Well, I'm going to take the two and swap their positions. And then, because my Y value was negative here, it's going to become positive. So it's going to be at 1, 0. Y is at 1, 2. And it's going to use kind of this blue color to show its change. Y prime then is going to be -2, 1. So again, the 2 and the 1 swap positions, and then the one that was in the Y spot becomes the opposite of where it started. The opposite sign, one, or positive versus negative. All right, finally we have our Z, which is our kind of purpley color at 4, 1. Now, again, I'm going to change the X and Y positions. So 1 is going to go first, 4 second, and because 1 was in the Y position, it's going to become the opposite. So -1, 4. So if we plot all these points over in our graph, shade these guys in. So our original triangle will shade with orange here. So this was our original triangle. And then our new triangle will shade in with some blue here. All right, so we got our Broncos triangles here, orange and blue. So we can see that our orange triangle has rotated to the blue triangle. We have another example here, and this time we're going to be doing a sequence of transformations. So your textbook will call this a composition or a composite transformation. So they might call this a composition or a composite transformation. And so we're going to be applying them in order, in the order that they tell us, and kind of walking through each step and using whatever we got from the previous step for the next step. So I'll show you what that looks like. So our first thing that we're going to do, we'll do it in, we'll use some purple for this first one. We're going to do this translation. And just a refresher on translation, I'm taking my X and Y values, and the change that's being made here, this arrow means that they're going to whatever is described by this change. So in this case, the X coordinate is adding 4. The Y coordinate is subtracting 1. Another way to read this is going to the right 4 and down 1. So in purple, we'll go to the right 1, 2, 3, 4, and then down 1. And that should be our new spot right there. And we'll call this P prime. It's our first transformation that we've done to our original point P. All right, the next thing that we can do, which we'll do in green here, is we will reflect over the line y = 2. I'll highlight y equals 2 in orangey color here. So y equals 2 is the horizontal line where the height is always at -2. So I apologize. Y equals -2 is the horizontal line where y is always equal to -2. So I'm going to go down and find where y is -2. This is my y-axis. -2 is right here, so it's going to always be on that y being -2. So I'm going to go through -2. We'll get it nice and straight there. And then for reflecting across this line, since it's horizontal, my change is going to be finding that vertical distance. So right here, I'm 1, 2, 3, 4 away. So I need to go 1, 2, 3, 4 to the other side. So we're going to do that in green. So we're going to go 1, 2, 3, 4 right there. And then here's where things change a little bit. Rather than calling it P prime, now I've made 2 changes. So we'll zoom into this real quick. So now I'm going to use 2 tick marks, and that stands for P double prime. We've made 2 changes rather than just 1. So because we're doing this composition or a composite transformation where we're doing a sequence of things, then we can describe each step by adding that additional tick mark. All right, so we're going to be a rotation of 270 degrees around the origin. And it doesn't specify direction, so we're going to assume counterclockwise. So again, we can apply our algebraic shortcut, or we can look at things visually. I'm going to apply the algebraic shortcut. So 270 degrees we saw earlier was if I start at some, we'll use our x and y again. If I start at some x comma y, then that's going to move to y comma the opposite of x. So the 2 x and y coordinates change positions, and then whatever was the x value becomes the opposite of where it started. So if we look at this point right here, this point in green is at -1, -6. So -1 comma -6 here. So I'm going to take -1, -6. And it's going to go to -6 comma +1. So my new point is going to go left 6. 1, 2, 3, 4, 5, 6, up 1. And now my final point plotted here will be P triple prime with 3 tick marks after the P. And now I have graphed each of these transformations. All right, for these 3, I want you to pause and see if you can figure out which of these transformations is being represented in each of the figures. And I will share with you what they are after the pause. If you said rotation for the first one, you would be correct. It's rotating counterclockwise. We don't know how many degrees, but it's rotating counterclockwise to get to here. The second one, if you said translation, our figure has slid kind of down and to the left here. We could describe that translation if we wanted to. And then our third figure here is being reflected across this y-axis. So you can see A has flipped over to the other side of the y-axis, C is flipped over, and B is on the y-axis, so B doesn't move. All right, our final example, and then I will put some kind of summary of concepts up for you as well. So we have here the point X, which is at -1, 5. We'll do X in blue. X is at -1, 1, 2, 3, 4, 5. Here is the point X. And then we have a sequence of transformations that it asks us to do. The first one is we're going to translate this X4 to the right. The second one that we're going to do is then we're going to reflect this across the y-axis. And then finally, we will rotate it 180 degrees about the origin. So if I translate it 4 to the right, that's like sliding it. So I'm going to go 1, 2, 3, 4. It's going to go right there. So right here in orange is X prime. Then if I reflect it across the y-axis is this axis right here. So I want to see how far away from it is. It is 1, 2, 3 away. So it needs to go 1, 2, 3 to the other side. So right here is going to be my new position. Going to be right here for X double prime. then finally, I'm going to rotate this thing 180 degrees about the origin. So one way I can do this is I draw a line through the origin like so. Then I can count how many spaces, 1, 2, 3 over, 1, 2, 3, 4, 5 up. So I should be 1, 2, 3 over, 1, 2, 3, 4, 5 down. And here, my new and final position, x triple prime. Again, I could have also applied that algebraic shortcut for this and taken the coordinates of x double prime and made the x and y values opposite. This is at negative 3, 5. I could have said that I'm going to go to 3, negative 5. All right, a few things that I wanted to share with you as just kind of a recap or review of all of our topics from Unit 2 is we have translations, and it's a slide that moves a point a certain distance in a certain direction. The shortcut for this is taking x, y, and applying this change of adding a value to x and adding a value to y. So that's our algebraic rule for this. A reflection is if we have some point AB, then it's like flipping over a certain line. So if I take this and reflect it over the x-axis, AB would go to A negative B. So the y value becomes opposite. If I flip over the y-axis, the x value becomes opposite. I go from AB to negative AB. If I flip over the line y equals x, then the x and y values change position. So A comma B changes to B comma A. And then if I flip over the line y equals negative x, then I still have that same interchange of x and y coordinates, but they also become opposite. So AB becomes the opposite of B comma the opposite of A. So if it was positive, it becomes a negative. If it was a negative value, it becomes a positive. And those x and y coordinate spots flip positions. Rotations. Again, I mentioned we would talk about some of these shortcut ideas. So we have some shortcuts for these counterclockwise rotations. So if I start at some point A comma B, and again, you could replace A comma B with X comma Y. For 90 degrees, I'm going to switch to negative B comma A. For 180 degree rotation, we saw this one in our previous examples. It becomes negative A comma negative B. Then for 270 degree rotations, A comma B becomes B comma negative A.